My pleasure to extend my special welcome to our facilitator, Mr. Dinushan Prabashitha, an automation engineer of MAS-KREEDA. As usual, before starting the session, there are a few announcements regarding today's workshop. We request you all to rename your Zoom meeting name with the name that you used for the registration. Also, just like the last week, we will send you the attendance sheet and feedback form in last 30 minutes. If you have any ideas regarding the session, please don't hesitate to fill the feedback form for the improvement of our webinar series. If you have any doubts during the session, you can send a message to the WhatsApp group or comment during Facebook Live, as Zoom chat has been closed due to the inconveniences that will be occurred during the session. And those questions will be discussed during the Q&A session. So we hope that you would be consider all those statements for a fruitful session of ARDIOFLO. So now I cordially invite our facilitator, Mr. Dinushan Prabashitha, to conduct today's session from now onwards.
Good evening, everyone. Hope all of you are in good health. As I told you earlier in the earlier session, today I am going to focus on the practicals because we have to do more practicals in order to get the knowledge of this Arduino. So I am going to do some practicals today. Let's start recalling the last session. We can do some inputs to the Arduino using a push button and light a LED bulb as a small recap from the previous session. So let's do it. Okay, let's start. Okay, I think all of you can see my presentation and the laptop screen, I think.
Yeah, we can see, sir.
Yes, sir.
Okay. Then I'm going to start the process and let's open a new project. In order to recap all the sessions, I'm doing this one. You can do with me this one. I'm going to add the Arduino as usual here with the Arduino, and I'm needing a push button. I'm going to type push button. You can have a push button. I told you about the pull up, pull down resistors in the last session. So here I'm going to use a pull down resistor. Okay, so I'm going to add the resistor. It should be 0.6 volt, 10K. You can choose any resistor in the range 1K to 10K. I'm going to add the ground here. And I'm going to connect this one to pin number 2, and I'm going to add the LED. Yeah, I'm going to add single color LED. So you need to get the single color. Here you can see this animated LED, right? And I'm going to insert here, and then you need the ground. Connect this one, and then I'm going to add this pin to pin number 2. This one goes to pin number 1. So here you need to add the power source. That means you need to apply here 5 volt from this board, or some outside power source. That means you can prepare a power supply module or something to power these buttons and the Arduino board. So I'm going to save this one. Okay, you can save this one and write a small Arduino code for this button and LED. Open new. Okay, you can assign 2 variables for the push button and LED. I'm going to assign 2 variables for push button and LED. I'm going to assign this one to number here, number 2, 0, 1, 2, push button attached to number 2. So I'm going to declare the LED button, LED pin here, number 3. So LED number 3. Can you see this screen?
Yes, sir. Yeah. Yes,
Okay. Can you hear me clearly?
yes, sir. We can
Okay.
hear.
Then I'm going to declare that the 2 pins, whether these pins are output or input. We can write pin mode and it's be a push button for an input. I think all of you can do this one with me. Then LED is going to output, right? Okay. Then the basics of the Arduino is here itself, so you can understand this one. So I'm going to read the input from push button. So digital read the pin with push button. In this one, we have declared the variable push button. You can read this one, and I'm going to insert this reading into another integer variable. That means I'm going to name it as a reading. Can you hear me?
Yes, 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 we can hear.
Okay. Then if condition you can use here. If there is a reading, that means a reading of high or number 1. That means high equals to 1 in the Boolean. High, low. That values, high means number 1 and low means 0. That means that is in the Boolean variable method. So this reading is going to read whether it is 0 or 1. So you can use this one like this. So if reading is number 1, then you can light the LED. If you are going to light the LED, then you have to write it digitally. Digital light LED to high. Okay. If you need to switch off the LED when push button not closed, then you have to write out of the if condition digital write LED low. That means LED will turn off in the turn off state. Always it will in the turn off state in the loop. When there is push button reading, only the LED will light. So you can understand in the code. So I'm going to save this one. Save. Example one. And I'm going to export compiled binary. So you can have a hex file. Okay, then double click this one, and you can here the hex file and click OK. Then you can run the simulation. If you click this one, you can see LED lights. Then it will turn off when the push button is not closed. If we close the push button, you can see LED turned off, turned on, as I said before. Okay, then I'm push button is released. Then we'll see what happens. It's not going to work. What's happened? It's my simulation, error in my simulation. So I'm going to check this one. Okay, you can see. I hope all you have done this one. So let's move on to the other practicals. That means, as we discussed previous session, we have discussed print to a serial monitor when button is pressed. I think you all can remember that one. Read button, input and light up an LED. This one also did in the last session, and also this one in this one. Read 3 buttons and light respective LEDs. This one you can do actually. I'm going to do it. Yeah, you can read actually 3 buttons and read respective and sorry. If you are going to use 3 buttons and 3 LEDs, then you have to add another LED here. LED, and all should be ground. This ground is a common ground for Arduino and the LEDs. Okay, you can assign this one to number 4 and this one for number 5. Okay, I think that will be okay. So then you have to assign another 2 push buttons. You can, I'm going to place it here and another one here, and then need another ground, and there should be a resistor to pull down 2 resistors. These are going to connect to ground, and this one going to connect here, and this one going to connect here. Okay, then this one connect to power. Am I too fast, or shall I slow this one?
It's just remembering last session, so it's okay. I think okay.
Okay. Then you can connect here, and you need to connect this one to. I'm going to connect this one to number 8, and this one going to number 9. Okay. This one is no. This one is not remembering part. I think we haven't did this one using 3 push buttons to 3 LEDs. I think.
Yes. Yeah. So it will be fine if you got a bit slower.
Okay. I think so. I think you all have got drawn this one in your laptops. I think so. I'm going to move forward. Here you can see this path goes to number 8, and this push button goes to number 9, and these 3 LEDs are in the D1 goes to number 3, 4, and 5, D2, D3, and here my first push button goes to number 2. So I'm going to write these 3 buttons. Push button number 1 should activate the LED D1, and number 2 D2, and number 3 is number D3. So I'm going to write this code. First, define the push buttons. Here you can use the same code, earlier code. Push button 1, you have to write this one as push button 1. This one goes to LED number 1, and you have 3 push buttons. So you have to declare 3 variables. I'm going to write as a push button number 1, 2, 3. So first one is for the number 2, and second one for number 8, and third one for number 9. Okay, then LED, 3 LEDs. So I'm going to declare 3 LEDs. LED number 1, number 2, and number 3. Number 1 is connected to number 3, and number 2 LED connected to number 4. Okay, and number 5. Okay, now it's okay. You have to define this one as a input or whether it is a output. So I'm going to change this one. All the push buttons are inputs. You have to change the variable type, and then LEDs are going to assign as outputs. So I'm going to assign that one as output. 3 LEDs, LED number 1, number 2, and number 3. Okay, can you see these letters clearly?
Yes, we can see.
Okay, then okay. Okay, then I'm going to read these push buttons. So you have to declare 3 variables for the reading. Then mean for the push button 1, I'm going to get this variable as reading 1. This one goes to here. Digital read push button 1. So I'm going to edit the previous one. Then I'm going to assign 3 variables. 2, 3. Here you can get readings of the 3 push button as like this. 1, 2, reading 1, reading 2, reading 3. Then you have to do a condition. That means if you have to apply if condition to read these variables, and then light the respective LEDs in your circuit. So if reading 1, that means this one, push button 1 is high, you have to write that one into the LED 1. So I'm going to write that one into LED 1. So like this. If reading 2 goes to number 1, then LED 2 should be high. That means LED 2 should be lighter. So if the reading 3 goes to high, then LED 3 goes to high. So you have to mention after this one, you have to mention out of the if condition to set the condition of the LEDs to low, because if we release the push button, it will turned off automatically. If we are not going to use here low, then it will continue to light up always in the void loop. So I'm going to turn down the all LEDs when there is no push button activation. So as you can see, here you can actually use else condition also. If you use else, you can turn down your LED also. For each and every if, you can use else condition in order to turn off your LEDs. It's easy to write this one like this. So I'm going to compile this one. Export compile binary. If there is no any issues, we can move on. Compiling was done. So I'm going to insert it here. Yeah, I think this one is the example one. Yeah, example one. So I'm going to refresh this one, and okay, then I'm going to run this one. So you can see it's running, and I'm going to push this push button. You can see here it's going to light up. So I'm going to push the one. You can see here it's going to light up, and other one. Here you can see the D1 LED going to light up. So I think you will understand this one. Is it clear, or shall I explain more?
I think it's clear, sir. I got that.
Okay, shall we move on to the next practical then?
Yeah. Yes.
Okay. You can see here we have did this one, and write the code to blink an LED. I think this one is very easy. This is a beginner example. That means if you are going to code in Arduino, all of you are doing this one. Blink your LED in the Arduino board. Shall I do it this one, or shall I move on to the other examples? Write the code to blink an LED. Shall I do this
if you
one?
do it, if you do it, that will be good.
Okay, I'll do it. Okay, right. I'm going to blink an LED. So I'm going to use this one. No, I will take another sheet. Okay. Sorry for the connection issues that I am having. So can you, I'm going to share my screen. Can you see the screen?
Not yet, not yet, sir. Still we can't see, sir.
Everyone, can you see this?
Yeah, now we can see.
Okay, now it's okay, I think. Sorry for the 2 minutes. I think is it clear? Oh, now it's clear, I think.
Yes, it's clear. Yeah.
Okay, sorry for the 3 minutes disconnection. So I'm going to blink an LED. I'm going to add the Arduino as usual. Okay, and I have to get the LED. LED, you can select animated. I'm going to select blue color LED for this time. So we have to get another ground. Okay. Then you have to connect this pin to any input pin, output pin. So here I'm going to use number 3 pin. So let's try the code. Okay. And how to assign that LED to a variable. So you have connected it to number 3 pin. Then you have to define that as output. Okay. Then you can blink the LED digital writing the high value to the pin. Seconds intervals. So after 500 milliseconds, it will be turned off. That means you have to write this LED pin to low. So this one will loop continuously because this is in the void loop function. So you all know this will in the void loop, anything will be run continuously in the loop. Okay, I'm going to export this one. So I'm going to save this one first. SLTC. Okay. Yeah, session 3 and example 2. Okay. Let's see whether it's going to compile. Yes, it's compiled. So I'm going to add the code. Example 2 and insert the X file. Okay. Then run the code. What is happening there? Sorry. What has happened? Let's check what is happening there. Here I'm going to write into LED number 3. Okay, pin is correct. Here number 3, 0, 1, 2, 3. Okay, that is correct. Then LED set to output and we will write LED to high. then 500, then LED to low. So you have to add the delay here also. That's the error that I have done. So export to compile library. Because if we did not add this delay, then it will automatically jumps to this high state. Then it will continue to stay in the high state. That's the reason that I am not getting a delay blink in the Proteus exam. Okay. The example 2. Okay, let's example 2, and I'm going to add the X5. Okay, now I'm going to run the simulation. Let's see what happens. Okay, you can see the blinking LED. You can actually increase the this delay time in order to remain the that means you can remain this light for several minutes also. If you need to faster blink, you can reduce this delay. I'm going to reduce this to 200, then you can have a faster blinking LED. Export to can you give me 1 minute? I will come back to you. Try this one for now.
Okay, sir. Okay.
Is it okay?
Okay, sir.
Is it okay?
Okay, sir.
Yes, sir.
Okay, sir.
It's okay. Okay. Thank you. You can try this one and get a blinking LED with reduced delay. Can you hear me? Can you hear
Yes, sir.
me?
Yes, sir. We can hear you.
Okay. Okay, I will continue this one. I think you all have export the compile binary. I will also export this one. Okay. Then you are sorry, I'm going to stop this one and can get the hex file, then run it again. So you can see here it will blink faster than the previous. Right. Let's move on to the next. Right here that we need to write the code to blink 3 LEDs. That one you can do it as a homework because you need to add 3 LEDs here and you can use the same code to blink the 3 LEDs. You can write define 3 LEDs here and you can digitally write high value to those 3 LEDs. Then write a delay. Then again you have to set the LED pins to low state. Then again delay. I think it will be easy for you. You can do it as a homework. Design nitride circuit. Before that, blink 3 LEDs. This one you have to do as a homework. Then here you can see turning on 3 LED bulbs sequentially when a button is pressed. Let's do this one. Turning on 3 LED bulbs sequentially when a button is pressed. So you need the 3 LEDs and a button. So I'm going to start out yes. I'm going to open my previously saved project. So here, this one with the 3 LEDs. So I have designed a circuit with 3 LEDs. You know how to add these ones from the previous sessions. Here the push button. With the one push button, you have to blink, not blink. It's there. Turning on 3 LED bulbs sequentially. When a button is pressed, you have to turn this one on, then this one, at last the 3 LED. So let's check what is in the code. Okay. Real one. Okay. Here I have defined button and then define the LEDs. Here integer variables you have to define, and then I have assigned this one as input and then 3 LEDs as outputs. These are common things in the Arduino. So this is in the loop. You can read the button state here to button reading variable. Then you have to check the condition whether button reading is 1 or 0. Then if 1, then you can write the LED 1 to high. Then after delay time, then it will set the LED 2 to high. Then after some delay, other pin will be set to high. Then all the finally in the final state, all the 3 LEDs will be light up. So I'm going to export this one. You can, I think you can note it down or try this one. Is the time enough for you to note this one?
A little bit time or
Okay, I will wait some time. Okay, you can note this code. I think you can take a screenshot even. Yeah.
yes sir, now fine.
Okay, this is the circuit I have designed. You can actually draw this one in your Proteus software. So I'm not going to explain these ones now because in the previous sessions I have discussed about the comport and the virtual terminal. So I'm going to insert that compiled code to this board, practical one, and okay. Then let's see what happened. So you can see this is the virtual window. Then I'm going to press this one. Here setting LED to high. Then you can see sequentially it will set to all set to light up position. So I'm going to stop again and run this one. and again. So if you press this button, you can see this one light up. Then after delay time, this one. After delay time, this one. Okay, you can see here setting the LED that I am writing on the serial monitor. These ones are reading on the button state is reading in the void loop function, in the loop function. So always this one will print into the virtual terminal reading button press. Here you can see in the example. Sorry, you can see in this code. In the loop here, read in button press. There is no any condition, no even nothing. So it's directly execute in the loop always. Only in the condition these ones will be executed, as you can see in the Proteus simulation. Okay, I think you all got this one. Is that right?
Yes, we got that. Yeah.
Okay, shall we move on then? Okay, then turning on 3 LED bulbs sequentially when the button press is done. So next one. Next one. This one. You have to try this one. This like Night Rider. That means you all have watched Night Rider. That car has some LED bulbs with the pattern. So you can create that pattern with this Arduino board. You have to try this one because it's a nice thing to do as a beginner to Arduino. So you can do this one. So I'm going to explain how to do it using Proteus. You should get the hands-on experience because this is very easy thing to do. So you can practice the coding with actual hardware with this example. And it's fun to have this kind of practical in your home even. Okay, I will explain how to do this one. So I have written a small code for that one. Even with the knowledge of loop, you can do this one. But here the basic things I'm going to teach you here. So I'm going to do it as in the basic with the basic knowledge. So you can use this one as a loop also for the forward loop and the backward loop. You all know how that LED works. That will light up sequentially, but it will turn off after passing that LED, and it will sequentially turn on the other LED. So you can understand how that works. So this is the example I have created. So I'm going to take here 6 LEDs. You can take any number of LEDs that you want. It will be more beautiful when you are increasing the LED bulbs in the circuit. If you are using that means 16 LEDs, it will be more that means more beautiful than the smaller LEDs. That means the 3 2 that is not enough for that circuit. I think you will use more than 10 LEDs. Here I am going to use 6 LEDs for the demonstration only. So here I am going to use the input button. That means when only the input, sorry, here I'm not going to use the input button. Only the when the loop is running, it will run continuously the that means the sequence of the LEDs. So let's try this one in the Proteus. Project. Okay, here the 6 LEDs. Here you can see the number 1 LED connected to number 3 pin, number 4, number 5, number 6, number 7, and number 8. You can connect these LEDs to these pins, and you can have a ground pin. And another thing, when you are using the Arduino boards, actually, when you are using in the actual projects, I forget to tell this thing in the previous sessions. You need to add a 1K resistor here, 1K or 330K, 330 ohm, not 1K, 330 ohm resistor here, because you are working with 5 volts in all the pins of the Arduino Uno. So you need to add 330 ohm resistor in series with the LED bulbs. Because some LEDs will work, because sometimes with the color, the LED takes more changing voltages. I mean, red will have a smaller voltage and green will have larger voltage. Like that, you can have various voltages for the LEDs. Around 1.7 voltage, I think these LEDs will work. So you need to drop that part of current flowing through this LED. So you need to add a resistor series with this each LED. So so sorry to for that. Now you can correct that one. So I'm going to correct this one. Okay, you can delete here. I'm going to delete. Okay, now I'm going to add resistors. I'm going to add 330K or something similar. Not K, 330 ohm. 330 ohm. 330 R. That means here. This one. You can use this one. Okay. Can rotate this one and rotate. Rotate. You cannot see actually. Can you understand why I am putting these resistors now?
Yes, because every LED takes different voltages, so you have to even it.
Okay. That means with the color, okay. If you are using
Yes,
same LED with the same color, then it will only take the same voltages for each one.
yes, okay.
Okay. So I'm going to check the pin numbers that I have written in the example. 3, 4, 5, 6, 7, 8. So LED 1. Okay. 3, 4, 5, 6. 3, 4, 5, 6, 3. This one goes to going to 0, 1, 2, and 3. Okay. I think you can draw this one with me, because now I'm going to correct this. with some resistors. So you can draw this one with me. And I'm going to check again. 3, 4, 5, 6, 7, 8. Okay, 3, 4, 5, 6, 7, 8. Okay. 7 and again 8. Okay, I think you all have finished this one. Okay. Okay, I'm going to save this one. Then I'm going to add that code to here, and okay, then I'm going to run this one. Here you can see how it is working. Here you can see. Can you see, or is there any connection issues? Can you see?
Yes, sir, we can see.
Okay. Can you understand this one? What is happening in the code? Oh, so sorry. I'm going to try to explain this one. Let me explain this code once again. Here I have defined the LEDs. You can name the variables as you want. Here I am going to use as LED1 and LED up to LED6. Then you need to define whether they are inputs or outputs as before. Then I will explain this loop. First one, that means this one. First one. You can see here. This is going to become high. Then it will light this LED. Then there is a delay time. Here I have declared a delay time variable. So you can change only this one, but delay time of these, each of the variables will be changed according to this delay time variable. So you can use common delay time for each and every LED in order to run this continuous sequence. So you can see this one. Then if we are going to write LED1 as high, then after delay time it should be low. So you have to write this one as a low. Then again, if this one is low, other bulb will light up. So you have to write LED2 into high state. Then it will be light up. So again, after delay time, LED2 should turned off. So you have to write low. Write the digital pin to low state. Then other LED, that means LED3 should goes to high state together. That means when this is turning off, other LED should light up. So I am going to use, I have used these two together before the delay time. After that, after delay time, this will be light up, this will be turned off. Then again, this light up LED should be turned off, and other LED should be light up. So you can see this one. Here after the sixth LED, that means my sixth LED, this one, after this one should be light up, because sequence is going 1 to 6 and 6 to 1. So not like this. If we are going to use 6, 1 to 6, then again jumps to 1 and then 6, it will be not like the sequence that we want. So we have to carefully reduce the numbers. That means reduce the pin number. Then we have to reduce from LED 6 to 1 like this. If we have to set the LED 6 to low position first. Then we have to light up the previous LED. After delay time, that one also should be turned off. Then the LED should be light up. Then after delay time, same procedure is going on. So at the finally, so you can see here digital right LED 2 pin too low. That means here you can see in the initialization part of the loop, LED 1 is going to high. So LED 2 is going to low here because these two, this part 10, this code part will execute in the at the same time because this is in the void loop function. So this code will continuously run in a loop. So this one and this one execute in the same time. I think you can understand that one. So here you can see how this is working. Do you need some time more explanation? No, something do you need if you don't understand this one?
So we understood that one, I think, pretty clear.
Okay, you can I think as a homework you can do this one by increasing the LEDs. Can you do this one as a homework?
Okay, sir. Yeah, we'll do it.
Okay, you can actually use here another there are 13 pins. We have used the push button for one pin, so you can use I think another you can use with the 10 LED. That means you can make this sequence with the 10 LED series. Can you do that?
Yes, sir, we can.
Okay, I'm going to move into next examples then. Okay, I think so. I'm going to stop this simulation. Okay, let's move to next practice. Okay, let's work with some LCD displays. Okay, you have to work with these type of LCD, various types of LCD displays when you are doing some projects in the university. So you have to use sometimes maybe you don't need to use an LCD, but anyway you can actually try to learn this one, how to use a LCD display with the Arduino board. Okay, I'm going to do this one now. Okay, I have prepared an example. Here, LCD hello world. Sorry, LCD display. Here you can get LM016L from this one. LM016M display. Alphanumeric LCD. Then you can place it in your in your Proteus PCB, then you have to connect these pins to, you can connect. I'm going to delete this one. As an example, I took that one here. So I am having this one. So you have to take the Arduino as previous, as discussed before. So then I'm going to add VSS and RW2. You need the ground. Okay. You can use these pins D4, D5, D6. Sorry. Okay. Okay, I think. Okay. Give me 2 minutes break. You can take a 2-minute break. Is that okay?
Yes, it's okay.
Okay. Thank you. Okay. Can you hear me?
Yes, sir, we can hear
Yes,
you.
sir, we can.
Okay. No. Okay. We can start this one. Sorry for the interruptions. Okay. We have connected RW and VSS to ground. So you can connect D4, D5, D6 and D4, D5, D6 and D7 to these pins. So let's look how to add this LCD display requires a special library. So you need to install this one. So today I'm going to explain you how to install a library, because several components of the Arduino will use some special libraries, like that means stepper libraries. There are stepper libraries, but you can actually do with the some is basic codings, but sometimes you can use libraries for that. And here this LCD also contains a library, so you have to insert this library into a Arduino codes. I'm going to explain how to insert this library. So you have to go to sketch, then include library, then you can click here manage libraries. Okay, it's going to download library index. Then okay, then you can type LCD here. Here you can see liquid crystal. This one should be installed in your Arduino. So you can click the install if you are not already installed in your laptop. So you can click here the install. I have installed this one, so it will be not appear in my case. So you have to install this one. Okay.
So it asks for a version. What should be the version?
You can install latest version.
Okay, sir.
Okay. Okay, I'm going to close this one. I think you can understand this procedure. Okay. So when you install a library, there are some examples in the library itself. So you can find this liquid crystal library examples. So you can see here blink, cursor, custom character display, hello world. As a programmer, you when you are starting programming, you all know you are beginning with some hello world examples. So here is also a hello world example. So you can use this hello world example as a beginner. So I have some sketch that I have done with LCD hello world. So you can get this one. I have edited some things from that examples. Here you can see there are hello world. In the example, there is hello world. Here I have edited this one as the hello SLTC. Okay. These are the keywords of the lcd.begins. These are the keywords of the library. You can find these keywords when you are going. You can go to documents. Here you can find the Arduino folder. There are libraries folder. So here, this is not the place. You have to go to the Arduino install location. Let me program files. Arduino. You have to find that one. Here. You can see libraries, and here you can see the all the libraries you had. Here the liquid crystal library. Here you can find the keyword text. Here this text file will include all the keywords that you can use with the library. Keyword 2 that you need to here clear is also a keyword. Print also a keyword. Set cursor also a keyword. Cursor, no cursor. Blink. You can actually use these keywords with this library. Then when you are adding a library to Arduino that means your sketch, into a sketch, you should use this code. That means hash include. Include means you are going to include this header file. .h means this is a header file. These are created by using C sharps and C++ codings. This Arduino supports C++ also. So actually, when you these things are, I think you will not require, but I will explain. Here you can see this liquid crystal CPP. This is the C++ program library has created. So this will contain all the instructions that you need to execute in the liquid crystal library, and the header file contains how to communicate with this CPP file. That means C++ file. I think you don't need this one, but for reference, I am telling this one. So, okay, I think you got how these libraries are created. Okay, I'm going to close this one. This is our example. This is the crystal. We have included the liquid crystal header file here. Then you have to here this one also a keyword. You can find this keyword from the this keyword section. Okay. Now you are going to define a LCD display here and named as LCD. Then here you can use any name. That means I'm going to use like test. Means you can use test. Then you have to change this one test. Yeah, test. Yeah, test. Yeah, test. Because you have created LCD display with the name test. Here the pins. These are the special pins that need to communicate with the LCD display. So in the comment section, you can see how the pins are going to connect in the Arduino. Here the LCD RS pins to digital pin 12. You can set any pin, then you have to change here. Here you have to change the RS pin, EN pin. If you are going to use these pin as it is, so you can use same pins as this command describe. So I'm going to use as it is. So you can use LCD RS pin to digital pin 12. RS pin means here this one. I'm going to connect it to digital pin 12. Okay, this one 12. And then here LCD enable pin to digital pin 11, enable min E 11. So I'm going to put it here. So then we have to save this one time to time because my one is crashing. I think your one's it's now it's okay because with the new version that will be stable. Okay, then LCD D4 pin to digital pin 5. Here D4 into 5. I'm going to delete all the things that I have done before. Okay, delete Okay, here D4 pin to 5. D4 pin, find the D4 pin. Okay, D4 pin 7, 6 and 5. Okay, 5. And D5 to pin 4. D5 here can see. Okay, D6 to 3, D6 here. Okay, and D7 to pin 2. Okay, sorry. Okay. And you can see here RW pin to ground. So I have connected to ground, and VSS pin to ground, and also that also connected. And VCC to pin, you can see VCC here. VDD is equal to VCC, so you can actually connect it to power. And here you can connect this one into power. Okay, I think, and 10K resistor, 5 volts, and 5 volt ground. Okay, now I think this will be enough to do the okay. I'm going to export this one. Export compile library. I think you can actually get this one from the library examples, and you can try this one. The here this keywords going to set the cursor into the location 1. That means this crystal display contains 16 by 2 characters. That means 16 characters in the row, and there are like that 16 character 2 rows, 16 character rows. So 16 by 2 display. This will indicate as a 16 by 2 display. So here you need to begin that display character list. So 16 means the row characters in a row, and number of rows here, number of rows in the display. You can see here. Here you can see that I have described earlier in the earlier sessions millis. This is a timer. Here it's going to print the values in the millis in seconds, because this have divided in 1000. This variable divided in divided by 1000, so it will print in seconds. You know that 1 second has 1000 milliseconds. So I'm going to export compile library. Okay, then you can now LCD hello world. Okay, you can print this. Okay, you can see here hello world. Hello, sorry, hello. Can you hear me? There is an internet connection error.
Sir, we can hear you.
Okay, then it will be fine. So you can see this one. Can you see this one?
Yeah.
Yes.
Okay. As you understand, what is the
So we couldn't hear the question.
what is these numbers means? What these numbers, that means 7. Can you say someone? Someone can you answer this one?
What was the
What is
question?
these numbers mean? What these numbers mean here? 28, 29.
I think that's the timer you increase millis. Yeah.
Right. Okay. In what that means, in what measurement units this timer works in this display? Can you understand that question?
Yes, you divided the milliseconds in thousands, so it works in seconds, but originally
Okay,
you divided it.
you got that one. Okay, thank you. So I'm going to run it again, see what happened. Okay, let me explain this one. So you can see this one, hello SLTC here. Here you are beginning the this LCD. So you have to begin this one. then it will begin. Then you can directly print using test means the LCD that you have created here. So you can directly print using this keyword. And if you need to set this, that means set the cursor to second row. That means this is the first row, this is second row. You need to set like this. This is the line 1 is the second row. If you are using here 0, that means you are setting the cursor in here. Sorry for the crashing. It's going to crash sometimes. Okay, sometimes it will work, sometimes. Okay. I think they have given me the permission. Okay. SLTC session 3 and LCD display. Okay, I'm going to explain this one. Here some errors. IVR program is not installed. So you have to install the IVR program from the folder. Okay. Save from this one. So you can see here. If you set the cursor to 0 position, then it will set into this row. That means first row. If you set this one as 1, then it is set to this position. Here you can actually use the number up to 16. This is the number 1 character number. That means this is second row. If you have to set that means character to 8 position in the 16th. That means there are 16 characters in one row, as I explained before. If you need to insert a character to 8 position, you need to add 8 here. Then you can add a value to second row 8 position. Let's try this one. Export to compile library. Again the test. Okay, I'm going to run this one. So you can see it here in the 8th position. Did you understand this one? What this cursor, set cursor means? Did you all understand this one? Can you hear me?
Yes, sir, we can hear that.
Did you
We didn't
understand this one?
Yes, sir,
Okay. Okay then. You can
so we can't hear you.
set anywhere in this 16 character row. Did you understand this one? Okay, this one. If you need to add, there is a connection issue. Can you hear me?
Yes, sir. Now we can hear.
Okay. Okay. I will ask you a problem. Small problem.
Okay,
If you need to print this one, this 35, that means this milliseconds into seconds into first row. Let's say it's as a 12th character. How do we write this one in set cursor method? Can you explain?
Yes, sir. You have to set that number 1 to 0, and then I think
This one
to
to
8 to 12. Yeah.
12. Okay, let's try this one. No? Export to compile library. Then I'm going to again open the Proteus. I think it's going to crash due to CPU load. Let's see what's happened when we set this one. Okay, you can see it here. Okay, now I think you all can understand what set cursor means. Likewise, you can understand each and every keyword by using it in the example like this. You can try this one at home.
Okay.
Excuse me, sir.
Okay.
Before moving on, we request all of you to mark the attendance sheet and feedback form given in the chat box. AudioFlow is one of the biggest initiates of the year. This will be a remarkable phase of learning Arduino. So there will be a segment called Do You Know through Facebook in order to seek new concepts of applications of Arduino. We invite you all to join with us to develop your knowledge further about this advanced topic. Thank you.
Hello, sir.
Sir, hello.
Hello.
Yes. Can you hear me now?
Yes, sir. Now we
Yes,
can
sir.
hear
We
you.
can navigate, but we can see the screen, sir.
We can't see.
Okay, I will share. Okay. Now I can. I think you can see the screen.
Yes, sir. We can see now.
Okay.
Yeah, and see.
Okay. Sorry for the connection issues. But anyone cannot understand anything because of this connection issue. Is there anyone? Did all get all the contents that I have shown in the screen today? Anyone miss any part?
Yeah,
I think
me and Dimanta got everything, but if anyone didn't got that, they can ask in the Q&A session.
yeah. Okay. Let's move on to the other part. Now I think you can understand this liquid crystal library and all the how to create a liquid crystal display. That means how to define this liquid crystal display and other keywords, important keywords, and you can refer that keyword text file from your library. And also you can try with the examples in the this liquid crystal library. Then shall we move on to some motor driver? Shall we trial some motor drivers in the Proteus? We have to do these things in hardware boards, because this one actually going to your heads when you are doing this one. Actually means with the hardware. This is only software and the simulation. I think it's better to do these things in practice and practice these things. Okay, let's do some practical with motor driver L298. I think you all have seen this one, motor driver L298 motor driver.
I have seen. I used it.
You have used this one, no?
Yeah.
Okay. Okay, let's do some practical by using this one. Yes. Did you all, I think, all install that library file for this L298 motor driver?
Yes, sir. We send everyone the email, including the library.
Okay, you have to install this one. I think you all know how to install these library files because we have installed the Arduino also like that.
Yeah. Yes, sir.
Okay. Let's try that one. As the last practical for today, let's do this one. So, okay, you can insert L298 from the list. L298. So 298. Here you can see the motor driver. If you have correctly installed in your Proteus, you can see when you type L298, you can see this motor driver, and you have to insert in your this sketch. So I have inserted this one in my sketch. So I'm going to run a motor using this motor driver. So you need to add the motor also. Type motor here, and you can get this simple DC motor model. So you need to have a simple DC motor. You can get this one and place it in anywhere you want. Then connect these out here. This motor driver can drive two motors. You can actually use this one for your projects like line followers and uh, arrow guiding robots and I think all kind of ground robots can be made with this uh, L298 motor driver. But when you are using large motors, you have to use different motor drivers other than this one. Like if you are using motors with high current high amperage, so you have to use different motor driver, because this motor driver only use 2 ampere. So then you have to connect these motors to the output. This is motor 1 output, this is motor 2 output. You can use that one. Then you can connect the terminals of these two outputs to the motor. Then here these two pins you should connect it to ground, and also ground should be grounded. And then here the 12 volt. So you can insert the generator. You have to move to generator, so you can select DC. So you can insert probe here like this. Then you have to type the voltage value. Here you need to insert 12 volts. So you can insert 12 volt here. And also here, this is also a DC generator. So you have to check as 5 volt. Okay. Can you understand this one? It means MI2 speed2.
So if you can that pin connection, explain the
Okay.
pin connection again. Yeah, that.
Okay. These two mode of in connection. Can you understand? And these DC generators. How I have assigned.
No, if it will better if you explain.
Okay.
From the beginning.
You have to go to generator mode, so you can find the DC generator. So I will do it again. Okay, and I'm going to add two DC generators. So then you have to connect this one into 12 volt. Then you have to set the properties to volts to 12 volt. Double click on the DC generator, then you can open the DC generator properties and add the 12 volt. So then another probe you have to insert, that means DC generator to input 5 volts. Then set this voltage value to 5. Okay, then you can see the connections to 12 volts and 5 volts. Yeah. Then you can connect this enable if you are using the single motor. That means this motor driver contains two motor driver can operate two motors. You can use this driver to operate only one motor. So if you are using one motor, you can select these three pins for one motor, ENA, IN1, IN2, these three pins for one motor, and IN3, IN4, and ENB enable B means these three pins connects to another motor. So in order to run the motor, these enable pins, that means ENA or ENB, these two pins should become high. That means these two pins should high in order to run the motor. And we can change the direction from IN2 and IN1. That means in the motor one, you can change the direction forward and backward by changing the state of these pins. If you have given the IN1 to high state, then IN2 to low state, then it will rotate to one direction. If these two pins state interchange, that means if IN2 become high and IN1 become low, then it will reverse the rotation direction. Likewise, the motor also works. So I'm going to test with this motor. Here you can see, I think, can you all see how the connections go into the motor driver and the Arduino board?
Yes,
Can
we
you
can
all
see.
see it clearly?
Yes, sir.
Okay. Here you can see ENA1 goes to here, number 12, and IN1 goes to number 11, IN2 goes to number 10. Here, other three pins goes to here, 6, 5, and 4. Enable pin B goes to number 4. Okay. Let's rotate this one, this mode. Or you can rotate any of these motors. Okay, let's move on to the motor driver example. Here you have to define all the pins in the motor driver to Arduino board. Here two enable pins have defined like ENA and ENB. I have connected to 12 Arduino 12 pin. You can see it here. 12 pin, and then ENB be connected to number 4, and IN1, IN2, IN1 here, number 11, and IN2 12. IN1 goes to number 11 and IN2 goes to number 10. Yes, sorry, small mistake. Okay, then you can see IN3 goes to number 6 here, and number 5 IN4. So you have to define these pins as outputs, because always you are giving output from the Arduino board to the L298 motor drive. So you have to define as output. You all know this one. And then here, with the knowledge of the Arduino function, you can create two functions to rotate two motors. Motor 1, digital write enable high. I have said that one because if you need to rotate the motor, you definitely need to set the enable pin to high. So you need to set the enable pin to high if you need to rotate the motor. If you set this one to low, that no need of this one, because this will ignore by the motor driver. If there is an enable pin voltage, only the motor driver will work the motor. Okay, this will continue to run up to 2 seconds. If this one in the loop, this will continue to move with the motor. Okay, let's start with the motor 2. This one, enable P, that means enable pin B. I'm going to write it as a high, then pin 3 going to high, then IN4 going to low. Definitely one of the pins should be low. Okay. Then I'm going to export the compile library. Here you can see I have defined two functions, but I have used only one function in the loop. These are commented. Okay. I'm going to insert this one. Here you can see the motor is going to rotate, as you can see. Okay, can you see this one? All can you understand and
Yes,
see?
we can see. Yeah.
Okay, no problem, I think.
Yes.
Okay, let's move on to Q&A session then. These are very important for your final project, I think. I will explain the IR sensor part in the next session with that PID loops, how to use the PID in the Arduino, like that things I'm going to explain in the next session. But in the next session, I will instruct you how to do the Arduino projects, final projects. So for today, I think this is enough. You can ask any questions if there is any question. Okay.
Excuse me, sir.
Yes.
Now it's time for Q&A session. We request participants to raise your hand so that organizing committee can unmute you to ask questions from sir, or you can send your questions to the chat box.
So can you explain a bit about that grouping to the doing the I think
Sorry, I didn't
that
get.
grouping for the final project? Can you explain that?
Right. Yes, you can group up to 3 members. Okay. You can do it by yourself, or you can group up to 3, 2, anyone. But maximum is 3. Is that okay?
Yes, okay.
Okay.
Sir, Which motor drivers can be used with high amperage motors?
Yeah, there are many motor drivers with high ampere. That means like BDL40. You can get from several manufacturing. For what type of application you need high ampere mode?
For like building battle bots and things. Yeah.
Yeah. If you are building battle boards, that means you need a high range of. Uh, if you are building a battle board, I will recommend to go with brushless motors with high torque. Okay. Most of the robots in the international robot competitions, they use brushless motors.
And then the motor driver.
Motor driver is the ESC. That means electronic.
Yeah.
You know, I think.
Yeah.
Yes, sir.
Okay.
Thank you, sir.
Okay.
And so, why can't we use pins 0 and 1 for the lightning up LEDs?
Sorry?
The pins in the Arduino board 0 and 1, why can't we use them to light up the LEDs?
Actually, this is a hardware serial port. The TX and RX reads the hardware serials from the when we are programming this one from your PC. That TX and RX will receive the data from the USB port. If you are connected to something like pull up or pull down resistor with the pull up or pull down resistor, it will not upload this Arduino sketch to your board. So better to avoid that 2 pins. If you are using like modules that needs to communicate hardware serially, that means if you are using a RF module, then you can use these TX and RX pins to communicate with that RF module.
Okay, thank you, sir. Got
Okay. You can connect these pins to the LEDs. Then you can see how the data transfer. It will blink continuously, like when you are transferring the data between
yeah.
your yeah. Right.
Sir,
And yes.
We can use a loop in night fighter circuit, right?
Sorry.
Yes. We can use a loop in night fighter circuit.
Yeah, you can use for loop like that. You can use. This is the only basic example I have used in this session.
Sir, can you explain that looping a bit? Yeah, with increment and decrement. Yeah.
You can actually use for loop like if you are using in my condition, I have used what I have used is 6 LEDs, no?
Yeah.
So you have to take integer. That means you have to define the variables up to 6. You can choose a condition. That means if you set I to 0 and I less than 6, like that, you can set in the for loop. Then you have to actually you need to get this I into the variable section. That means you have to define the variables including I.
Oh, yes, sir.
Including I. Then you can loop the each and every LED pins in a for loop.
So
I will explain this one in the next session. How to use these LEDs with the for loop. Is that okay?
That's okay. So, yeah.
Okay. Because I need to show it.
Yeah.
Now this is for the Q&A session. Time for the Q&A session. If I'm going to use the explain this one, it will take all the time.
Yeah. Yes. Yeah. Okay. Thank you.
Okay.
Thank you.
Definitely, I will explain this one in the next session.
Okay, sir, that's
Yes.
fine. Yeah.
Okay.
Thank you. And what do we connect to 5-volt and 12-volt pin in the L29 driver in the real circuit? I mean, a physical circuit.
Physical circuit 5-volt and 12-volt. You need to make a small power supply circuit. You can use regulator 12 volt regulator for 12 volt and 5 volt
Okay.
regulator for 5 volt, and you can insert the voltages in that L298
Okay.
is the motor driver.
Yeah. Okay.
You have to make a small power supply for them, because we need to supply the voltages separately. We cannot get the 5 volt from the Arduino board.
Yeah. Okay, so thank you.
Okay. What is the difference between digital write and the analog read write? Yeah, I think I have explained in the previous sessions. Did I explain this one?
Yeah, maybe he didn't got the part. Can you explain again?
Yeah. Digital read is the when you are going to read the pin state from an Arduino board. So you need to use this digital read function. And digital write means if you are going to write, that means if you are setting the state of a pin, then you have to use the digital write function. Analog write means when you are doing the same thing with the analog pins, then you can use analog read and write. Actually, analog write can use varying values up to 0 to 255. Okay, I think this is the basic explanation. So should we submit the homework? We have mid-semester examination. That's why I'm asking that. So should we submit the homework? No, you can do the homework by yourself in the home. I think no need to submit that one. I will send the answers for that activities that I have given you. Is that okay?
Yes, sir.
Yes, so that's fine.
Okay.
So there are only I mean if we are building a nitride circuit, we can only use like 13 or 10 to 13 pins for bulbs. Is there any way to increase the number of bulbs?
Yeah, you can use. There is actually chip called LED drivers chips. You can buy it using any electronic shops. Do you need to explain this one further? Because I can explain this one also in the next session.
That will be fine, sir.
But I will tell that one. This one, you can buy this LED driver circuit. You can drive using. Actually, you need to insert only 2 pins of the Arduino board, and you can drive up to 6 LEDs from this chip.
Okay, sir.
Then you can actually calculate number of pins in the Arduino, and then,
about yes, sir. Yeah, got that. Thank you, sir.
Okay. Is there anything? Is there anything you need to clarify on the today's session?
yeah, will there be any serial communication modules like Bluetooth and IR in the next session? Or
I'm going to use actually the IR sensor, because today I have planned to discuss that one also, but with the time I cannot do that one because it will help you to do your actually your project. So
okay,
I'm going to discuss about the IR part. And do you need to do you need any explanation about the Bluetooth and GSM modules also? Because I think if I find the library file for that GSM module, I will do that one also.
yeah, if we have the time, yeah, we can consider yeah, in the next
Okay,
lecture. Yeah.
okay, we can do it.
Okay.
You have to do the practicals by your hands because you need to engage with these practicals physically, because these are actually simulations. You cannot understand the practical situation by doing these kind of simulation. Actually, you need to do it physically.
Yes. Yes.
If you are doing it physically, you can understand what we are using that resistors for, LEDs, like that things. You can understand why we want to use this one. You can try without using the resistors, and try using the resistor, then actually you can burn some LEDs also.
Yes, we'll try.
Okay, is there any questions? I think time has finished, no?
Yes, I think so. Questions are also over. Yeah.
Okay, shall we wind up then?
Yes, sir.
Okay.
Yes.
At the end of this whole webinar series, there will be a final simulation project which can be done as an individual or group project. If you prefer to do as a group project, then you can have maximum 3 members in your group. We will send you a Google form to fill the details of group members within this week. Now, we will remark the end of the third workshop of ARDIOFLO. Before ending, we would like to extend our sincere gratitude to our facilitator, Mr. Dinushan Prabashitha, for your time and effort on us, and also the participants present here today. We will surely meet with our fourth workshop on next week. Till then, stay safe and have a good night. Thank you.